Hi class, good job on studying calculus 1. We are on last section, which is the 7.1. And after this one on calc 2, you guys are going to learn so many beautiful things about the theorems of calculus and what integral does. So let's study substitution. So earlier in 6.2, I explained about these three. So I want to go over quickly one more time. So example 1, as I see that I see two functions combined. So from here, I could guess that this came from chain rule. So I need to guess either come from here or second one. So when I see it, I see inside of the derivative out there that I assume that my cosine x cubed was the derivative. So what would be my antiderivative? And I'm going to guess, if I guess from here, similar form will be cosine comes from sine as an antiderivative. So I'm going to try with sine x cubed plus c. As you see, it's an indefinite integral. I need to plug in c here. So if I take a derivative and then check one more time by chain rule, do you see that cosine x cubed and then 3x squared as dx? So yes, this is the answer. But Yana is still having hard time. Then you can always substitute. So in this case, I'm gonna help you. How we substitute? I'm gonna substitute t as x cubed. Then next, if I take a derivative, dt dx will be 3x squared. So as you see, dt will be 3x squared and dx. So I want you to puzzle carefully. I see that 3x squared dx on your function, 3x squared and dx in your function. That is what? That's dt. So I'm going to copy. That's the same thing as dt. Just a keep puzzle. And then I have a cosine t, which is easy to take integral, which is a sine t plus c. So I'm almost done. From here, you can substitute back. So sine t was 3x squared. Oh no, x cubed, right? T is x cubed from here plus c, which I get exactly same answer. Okay, so there are actually in-class activities, but since I did this one, I want to try. But the tricky part of here is what you're gonna take a substitution. So I'm gonna give you hint next three. So I want you to try by yourself and then compare the answer with me. In this case, all of them, of course, you can do it at once if you see it. But if you don't see it, I'm going to substitute t as x to the fourth plus 5. So continue the t, and then you can find all the other values. Next one, what do you think has to be substituted? T has to be cosine theta. And then last one is a little bit tricky. T has to be 1 plus e to the t. So I want you to try this one as a substitution and then try 1, 2, 3, okay? So let's look at my answer briefly. So if you get in-class activity 1, I hope that after you're doing second, third time, you do better. So that's what I got. And then look at my work. And then appetizer 2, that was just a straightforward. If you take a derivative, this one, you get that one. So just don't forget C. And then in-class activity 2, that looks actually tough, but if you substitute, sorry, this one shouldn't be t, should be m, because I want to use a different variable. So if you simplify, it all turn out to be just simple 1 over m dm. That's what I'm talking about. It gets really simple compared to this one, so you will see the pattern better. So that as you've been doing homework, you see that 1 over m. We've been saying that natural over m. However, we have to put the absolute value. When you go backwards, it has to be always positive. So m is 1 plus e to the t, and that's my answer I got. So keep trying with me. Actually, substitution is really fun for me. It's like a game, so keep playing one by one. So class, it's gonna start some fun games start. So if you got the big idea of how to substitute, actually all the rest of them is gonna work. Just you need to see that what would be the function that you need to substitute. So just be careful. So now look at this one. When we have integral tangent theta d theta, I'm not taking derivative. Derivative will be easy as a secant square, right? However, I'm taking antiderivative. So think about anything that when you take derivative makes tangent. We didn't learn that yet, right? So what will be definition of a tangent? Which I can see as a sine theta over cosine theta and d theta. Do you agree? Now, I like to substitute because I still don't see what's gonna be. So I want to substitute. So should I substitute sine or cosine? Which one? You would like to do actually sine, because look at sine is easier, and then sine taking derivative cosine. So look at dt d theta is cosine theta, and dt is a cosine theta d theta. So do you see this expression? I only see sine theta d theta, and this is 1 over cosine. So if I substitute, I cannot find sine theta d theta that. This part's not gonna work. Then what if I'm using t as a cosine theta? Then dt d theta would be negative sine theta. So sine theta and d theta, and then I can put negative here because I want to match this. So let's substitute. Integral cosine is going to be 1 over t. Sine theta d theta is negative dt. So just a keep puzzle. Cosine theta is 1 over t. Sine theta d theta is negative dt. Negative, we can put it outside. And then dt. So when I look at this, now I can take the integral of 1 over t. What is it? Again, that's going to be natural log of t. Don't forget, right? Little confusing here. So natural log t, if you take the derivative, you get 1 over t. T will be always a positive. And then plus c, and I'm going to have a negative coming out from here, and plus c. So now negative natural log of c value, t value is cosine theta, and plus c. Okay, that's the answer. So I want you to take a derivative, and then if you can get also tangent, if it doesn't, your answer is correct. And as you see, I see it. Yeah, just 2 steps, take a derivative. So you have to choose which one will be right t as substitution, and let's go to main dish. Okay, so let's look at main dish. Why were you surprised just to see in class activities the same question again? So I want you to, without looking at mine, think about one more time if you can do it, and look at the answer, and then see. You can totally do this one. I know since you just saw a second ago, I'm sure you can all do it. Okay, class, so let's look at main dish 1. And main dish here says, give a substitution w. So we have to decide what w will be, and constant k, and then following integral in form of integral k, w, n, and dw form. So just basically same thing what we did, and just to substitute it. And when I see this one, do you see that how many functions combined here? How many functions combined here? I see 1, 2, 3. That means you probably have original function, 3 functions. They take derivative shows this way. So what should be w? What should be w? Staring at it, what looks like a most outside function. So I kind of see the picture here, like cosine e to the x to the 3rd power. I see 3 functions here. One as a 3rd, some cube, and then second function cosine inside function e to the x, something like that. So when I look at this, substituting complicated one will be probably easier. So I'm going to set cosine e to the x as my w. Then what will be dw dx? That's going to be sine negative e to the x. You see another chain rule, e to the x, dx already outside there. So that's what I have. Then if I rewrite this one as dw, that's a sine e to the x and e to the x dx. So I want you to see if you can puzzle. Let's substitute integral. Now cosine cube e to the x. I already substitute cosine e to the x here. So can I write it w to the 3rd power? So I'm done with this part. Now if you look at rest of the part, e to the x, sine e to the x dx here, only negative, so I can give negative to other side. Then do you see I can do negative dw? Yeah, I'm done. So if I plug in this one back, because they want to keep this form, negative w3 and dw. I'm not done yet. Do we know how to take integral of this one? Yeah. So we can actually take an integral, but all they're asking is this. So do you see the k value? Do you see the n value? And then w is going to be cosine e to the x. Yeah. If you go back, and then you can take antiderivative, which you see that 1 over 4 x to the w to the 4th power. And then there is going to be negative. So if you plug in, and don't forget c, if you plug in w, that was your antiderivative. Your answer is this, and you may see on the homework, but if you take integral, that's what you're gonna get. Okay. I hope that this main dish was pretty fun. Let's continue. If you look at the next question in class activities, can you guys try and then compare with me, find what the value has been substituted carefully. Okay, how is your in-class activity go? So did you see the difference is top and bottom? That is an indefinite integral. This is a definite integral. Indefinite integral will be a function. Definite integral will be the number as area under. So if you're doing the way, I wonder if you got this one. I want to tell you that this is wrong. Okay? If you got something like this, where did I get wrong? Where did I make mistake? This is where your mistake is. Since you change your variable as a t, instead of you getting 0 to 2, now that was respect to x. So let's plug in 0 here, then you get the t value 0. And if I plug in 2 here, then you get the t value 4. So if you actually do substitution, you don't have to go back and then compute again with 0 and 2. You can actually do it from here. We'll get you same answer after the substitute back. So let's see from here, what am I getting? It's going to be, I got this one instead of 0 to 2. Now you have to write it 1 over 2 e to the t, and from 0 to 4. So I'm going to plug in. That is going to be 1 over 2 e to the 4th power minus e to the 0 power, which is a 1 over 2 e to the 4 minus 1. So do you see that's slightly different? I got e to the square, but you cannot because I'm using t as my variable. T as my variable. Then Younghan, how can I get this one correct? So you can do here, if you want to substitute back, you can substitute back your e to the probably x squared from 0 to 2. Because now I change to x. So 0 to 2, if it's a t, it's going to be 0 to 4. Then if you substitute again, do you see the e to the 4? E to the 4 minus e to the 0's power, which is negative 1. So there's a nice thing about substitution of integral there if it is indefinite integral. You don't have to go all the way substitute back. You can just keep using as a t, but careful about your domain is going to be changed because your x changed to t. So plug in this one, or plug in 0 to 2, then you will get 0 to 4. So careful very end, whatever the variable, don't copy of x domain 0 to 2. Now you have a t domain from 0 to 4. Okay, that's what I want you to be careful when you do definite integrals. Okay, class, 3 questions left before the semester end. Almost done. So when you look at this, a little bit scary. It's trig. But trig function, yes, you have to actually see that trig functions are easier. So choose what will be your substitution. When I look at this, if I substitute tangent, I see that their derivative will be 1 over cosine square d theta. So I'm going to use t as tangent theta. Then dt d theta is 1 over cosine squared theta. Therefore dt is 1 over cosine squared theta d theta. So now, do you see puzzle here? I have this one I can substitute, and I got 1 over cosine squared theta d theta there. So I have my integral, and substitute is going to be t cubed, whoa, d t. That's it? This simple? Right? But now, should I use 0 to pi over 4? That's for the theta, right? So I cannot use these two. Now I have to use for t. So let's plug in. When pi over 4 as a tangent pi over 4, what was it? That's 1. How about tangent 0? That is a 0. So basically, if you substitute in a definite integral, this is going to be your substitution form. Is it so sweet? So since it's going to be number, we can just plug in an antiderivative, which will be 1 over 4 t to the 4th power, and then we can plug in 0 to 1 in this case because it's going to be the number. So if I plug in 1 over 4, 1 to the 4th power is going to be 1 minus 1 over 4 times 0. So I get 1/4. What a nice number, right? So nice and neat. So since this one is exactly the number, either you approach this one with 0 through pi over 4, you can actually put it into your decimals and check. You will get exactly same number in indefinite integral, and you don't have to substitute back because they already substitute here, and then your domain is changed with in terms of the t function. Okay, so once you practice substitution, it's actually pretty fun. So I want you to also see in class activities, and then try to see that what do you need to substitute, and then do one more step, and then do you see your derivative function in there. For me, I see both of them. I see my original function t, and then when I take the derivative, I see that dx. So I want you to try in class activities and then compare with me. So how's it going? Let's look at our in-class activities, both getting better. So careful this time when I substitute, their only work can become 4 to 2. So I don't like to have a 4 to 2 as my domain, so I switch 2 to 4 with taking negative. From here, straightforward and careful. Don't stop here. You have those integral natural log properties, which subtraction becomes a division. So I put it as a natural log of 2. And if you talk about as a graph, if you see this graph is a negative 1 over x graph, and then shift it to the 5 to the right. So my asymptote is going to be 5, and my function from this one, negative x, will be this way. So I have that one, shift 5. So do you see that my area has to be positive from 1 to 3? My area is natural log 2, which is really, really beautiful. Do you think this number is bigger than 1 or less than 1? It's less than 1, right? Why? Because ln E is 1. E is 2.7, so this is 2. Should be less than that. Okay, so now we are going to start the dessert 2. Last question of the semester. Yeah, let's celebrate. Yeah, and if you want to try, you can actually try. Let me see if I can give you the hint. So you can try without looking at the substitution, what I substitute. You can do trial and error. It happened to me too. I see 1 step and 2 step, 3 step ahead. If you don't see it, the hint, 1 plus the square root of x, okay? And then figure that out, and then let's do it together. Okay, last question of this semester. So I wanna take the integral, and as I gave you hint, I'm going to use this as a t. You could do this one, but that 1 is not gonna be helpful. So you know that if you take a derivative, 1 drops out. That's why including 1 here. So the x will be 1 over 2 square root of x. So the t is 1 over 2 square root of x and dx. Okay, let's look at one by one what is going on. So I'm going to rewrite this one and then see what is happening. So I see the integral square root of t. However, when I look at this one, I see that my dx is right here and not helping much in here. So what should I do? What should I do? I'm going to see that all I need to have the dx. I don't need 2 square root of x. So I have to send it to other side, because that's how I'm going to substitute. Then staring at it, do you see anywhere what square root of x will be? Keep finding, keep finding. Do you see anywhere I can substitute, and then what term do you need to rewrite? I wish that was everything t. So now I'm going to play with this, and you see that t minus 1 is square root of x. Don't forget, everything is in there. You just have to keep look for it, how I can substitute. So I can rewrite, this will be 2 square root of, square root is, whole thing is, I can write as t minus 1. So t minus 1 dt, there you go. It's kind of weird, right? And that's dx. Just look one more time. It's the same idea, but I couldn't cancel 2 square root of x. I know that to get rid of square root of x. So I look back, if I can manipulate my equation, I see that I can rewrite square root of x as a t minus 1, so that I can replace everything to t. So if I continue from here, dx is going to be rewritten this way, which is 2 times t minus 1 dt. Now it looks more complicated. Actually, if you see the big picture, it's not. It looks like it's a product, but if you multiply in, so with 2t, 3 over 2 minus a 2 square root of t, which is 1 over 2, and dt. So as you see that I can change to power function, which will be easier to take antiderivative if you have a practice. So let's see that when what makes this one comes from 5 over 2, right? And I have a 2 here. I have to get rid of the 5 over 2, so I'm going to multiply. If you don't believe me, just take a derivative of this one. If you get t3 over 2, right? Do you see that? And then that 2, I kept it. One more time, 2 to the negative 2 to the t1 over 2 power. That will come from 2t to the 3 over 2 power, and then 2 over 3 I need to multiply. Okay, I see my mistake. That one has to be 2 over 5, right? So that's why we always have to take derivative one more time and double check. And then plus c. So it's going to be plus c. So let's organize. If I organize 4 over 5 t to the 5 over 2 minus 4 over 3 t to the 3 over 2 plus c. And then don't forget, very last, we need to substitute all back. So 4 over 5, t was 1 plus root x 5 over 2 minus 4 over 3, 1 plus square root of 3, 5 over 2, 3 over 2, and constancy. So that's the answer. It was a quite of work, and then just try to think carefully one by one. If you do one by one without looking at my work and making mistake, look at it, that will also make it strong. So this is it, everybody. Excellent job through this semester, and there are a lot of information. So those who need help or anything, just try to email me, and then I will try to meet you before the final or during the final exam day. So good luck rest of the semester and final exam, and I will see you last day orientation, probably Zoom, also some of the Zoom meeting personally. Okay, good luck studying.